This is a calculation on chemical composition stoichiometry involving purity of a sample. A sample of copper 2 oxide, formula provided, is only 40% pure. What mass of the sample would contain 3.20 gram of copper? We're given the relative atomic masses of the constituent elements. Let us get straight off into the solution. And in this video, we're going to use the method of dimensional analysis. Now, let us establish that there is a difference between the sample and the ore in the sample. So these two are different. You have the sample, and the sample contains the ore. So since this sample contains the ore and is only 40% pure, it means the true ore, which is the copper 2 oxide, makes up only 40% of the sample. The sample is the full composition, which is 100%. So we have this representation. So we have this as the representation. If we have the whole sample, this is the whole sample here. This may represent what we intend to have. This is the whole sample. The whole sample is everything here, and this is 100%. That's the sample. But the particular ore, copper 2 oxide, is only 40% of the sample. So let us highlight this with another color, and now we have something like that. Okay, this is what we mean. This is just 40%, and it is CuO. 40%, just 40%. So this has to be established. The sample is different from the ore. Now let us continue with this. The first thing to do, having established this, is to calculate the molar mass of CuO given to us. Molar mass of copper 2 oxide, let's see. Relative atomic mass of copper is given to us already, right there, 64. Plus, that of oxygen is also provided, 16. By adding this together, we have 80 gram per mole. Now, there is this relationship between the molar mass of the whole compound and the individual masses of the constituent elements. So we can set up a proportional relationship here. We're dealing with the mass of copper, 3.20 gram of copper. So we're setting up a relationship between copper and the molar mass. Now let us get straight into it. We go with the mass provided, 3.2 gram of copper, 3.20 gram of copper, and relate it to the mass of copper 2 oxide. In this calculation here, we observe that out of the 80 gram in 1 mole of copper 2 oxide, 64 gram is contributed by copper, as we have observed. So that is a relationship. It means 64 gram of copper is present in 80 gram of copper 2 oxide. And that's a relationship we can set up. Using the method of dimensional analysis, the denominator is our target. We want to set up a unit here that will cancel out this. So gram of copper has to be set up here, and that is based on this relationship in the molar mass there. So we have 64 gram of copper present in 80 gram of copper 2 oxide. The molar mass establishes this. And now from here, we walk into the sample. So let us go for the sample. We must find a way to cancel the gram of copper 2 oxide. The denominator, once again, is the target. There's a relationship between the sample and the ore, as established earlier. 100% indicates the sample, 40% for the ore. So we go, to cancel out copper 2 oxide, we go 40% of the mass of copper 2 oxide. 40% gram, and that is contained in 100% gram of the sample. 100% gram of the sample. Beautiful. This is the relationship. Now, as we observe, the units already give way. Gram of copper 2 oxide eliminates gram of copper 2 oxide. Gram of copper eliminates gram of copper. Gram of copper 2 oxide eliminates gram of copper 2 oxide. And the surviving unit is now percent gram of the sample. Actually here, this needs to be well clarified here. What we have here is actually 100%. 100% the gram of the sample. So percent unit here knocks out the percent unit here, of course. And now, by multiplying appropriately and dividing, we can get our final answer very quickly here. By multiplying and dividing appropriately, our answer is 10.0 gram of the sample. Of course, that can be done with an electronic calculator. Very simple. This is our final answer, and that is the option B right there. All right. Now, attached to this video are 2 quizzes to test for your understanding of the content of this video. I recommend you take the quizzes, and of course, the explanations are provided once you click the answer. Now, in addition to that, there is a link in the pinned comments that will take you to the test on chemical composition stoichiometry. There are 20 questions to be attempted in 30 minutes. I recommend you take the test. This will help you establish your mastery or understanding of the topic, chemical composition stoichiometry. Finally, there is room for improvement if you need to study the full presentation of the topic. You can click on yet another link provided in the pinned comment to study the topic, chemical composition stoichiometry. So study, learn, and enjoy. Thank you for being part of this session, and see you in my next video.